Lesson 8.4 is solving polynomial equations in factored form. So this is the key here. We're finally going to look at these polynomials and we're going to be able to figure out what the value of x is. Here it says you've learned that the property of 0, which means for any real number a times 0 is 0. This is the same thing as saying for real numbers a and b, if a equals 0 or b equals 0, then a times b equals 0, no matter which one it is. Because a times 0, if this was b, equals 0, and if b times 0 for a, you're going to get a 0. That's the zero product property. Basically it says if a times b is 0, then a equals 0 or b equals 0. So it's pretty much common sense. Excuse me. The zero product property is used to solve an equation when one side is 0, so that's important, and the other side is a product of polynomial factors. So we're going to be looking at the factors. The solutions of an equation are also called the roots. So they're also called the roots. Okay, so here it says go ahead and solve the equation. Notice the first step, it is already set to 0, and lucky us, it's already in factored form. So that means this product is 0 if I can set x minus 5 equal to 0, or if I set x minus 1 equal to 0. So if either of these factors is 0, we're good. Well, to solve this, I would add 5 to both sides, and to solve this one, I would add 1 to both sides. So basically, these are my solutions. This product will equal 0 if x is 5 or if x is 1. And you can check it right over here. If I put in the 5, for example, I'll have 5 minus 5 times 5 minus 1, which is 0, times 4, which is 0. Or I'll have, if I put in the 1, I'll have 1 minus 5 times 1 minus 1, which is negative 4 times 0, which is still 0. So that's what we're going to do in a little bit. Right now it says to solve a polynomial equation using the zero product property, you may need to actually factor the polynomial. These have already been factored. Or we need to write it as a product of other polynomials. The first thing we're going to do is look for the greatest common factor, also known as the GCF, of the polynomial's term. This is a monomial with an integer coefficient that divides evenly into each term. So what I'm doing is I'm looking at these terms collectively, and first I'm going to look at the coefficient. Both of these are divisible by 4, so I'm going to use a 4, and both of these are also divisible by an x. So the greatest common factor is 4x in this case. So then I just do my division. 4 divided by 4 is 1, x squared divided by x is x, minus 4 divided by 4 is 1, x divided by x is 1. So this is x minus 1. But the way that you write this is 4x times x minus 1. You must have both factors, the GCF and then the resulting factor. In this case, it's a binomial. So if I look at this one, both of these terms have an r, and that's all they have in common. So my GCF is r squared divided by r is r, 2rs divided by r is just 2s. And you can always check these. If you were to distribute the monomial factor back over the binomial or trinomial, then you will get the original polynomial. R times r is r squared, r times 2s is 2rs. So let's look here. With the 6 and the 14, the greatest common factor is a 2. With the w to the third and the w to the second, the greatest common factor is a w squared. When you're looking at variable terms, if you look at the lowest degree, then that's going to actually be your GCF portion. So I have 2w squared times 6 divided by 2 is 3, w cubed divided by w squared is w, 14 divided by 2 is 7, but this is subtract, w squared divided by w squared is just 1, so we don't put that. So the answer is 2w squared times the quantity 3w minus 7. Now it says solve the equation. Number one step when you're solving the equation, if we look back up here, it must be set equal to 0. In this case, it is, so we're good. But unlike this first problem, this is not in factored form. So I cannot set it equal. I cannot set it equal, like I can't go a squared equals 0 and 5a equals 0 because these are not factors. So I'm looking back up here for the greatest common factor. They both share an a. So I'll factor out the a, and a squared divided by a is a, plus 5a divided by a is 5, equals 0. Now I set each factor to 0. So my first factor was the greatest common factor, so a equals 0, and I'm done. Nothing else I can do with this one. And then I have a plus 5 equals 0. So when I solve this, a equals negative 5. So these are my two solutions. And again, if you put them into the original, 0 squared is 0, plus 5 times 0 is 0, 0 plus 0 is 0. So that works. Here, negative 5 squared is 25, and 5 times negative 5 is negative 25. Negative 25 plus 25 plus negative 25 is 0, so it does work. Let's do the same thing with this one. With a 3 and the 9, I can factor out a 3. S and s squared, I can factor out an s. So I have 3s as my monomial. When I divide, this gives me an s minus 3 equals 0. So I get 3s equals 0, and s minus 3 equals 0. Well, if I divide by 3, s equals 0, and if I add 3, s equals 3. So those are my two solutions. If we look at 5, the first thing we have to do is look back up here. It must be set equal to 0. So I have 4x squared. I'll subtract 2x to set it equal to 0. Now I can factor out a 2 and an x. So my monomial is 2x. When I divide, I get a 2x minus 1 equals 0. So 2x equals 0. 2x minus 1 equals 0. And then I ran out of room, but you should still have room. I will write it up here. So if I divide by 2, I get a 0. And if I add 1 and divide by 2, I get a half. So when I solve this one, the answer is a half. Okay, next type. Vertical motion. This is really, you're going to learn a lot about this in a physics class. It says a projectile is an object that is propelled into the air but has no power to keep itself in the air. So there's nothing forcing it, like no engine or anything to keep it going. A thrown ball is a projectile, but an airplane is not, because the airplane has the engine to keep it going. The height of a projectile can be described by the vertical motion model. So here it is, and this is important. This is in feet. Your general equation, and you're going to have to memorize this. H for height equals negative 16t squared plus vt plus s. T is the time in seconds that the object's been in the air. V is the initial velocity, vertical velocity, so it's the force that you're throwing it with, and s is the initial height. So first we're going to go ahead and set this up. We have a startled armadillo jump straight into the air with an initial velocity, vertical velocity, 14 feet per second. After how many seconds does it land on the ground? So my height is negative 16t squared, that's standard, plus the initial vertical velocity is 14, so 14t, plus it says that he's on the ground. So it doesn't say that he's on a stump or anything, so we're just going to say plus 0. So now to solve this, I want to know when he's back on the ground, so I set it equal to 0. And now I have to factor out the common factor. If I have a negative leading coefficient, I am going to factor out a negative. So I'm going to factor out a negative 2 for both of these and a t for both. So my greatest common factor is negative 2t. When I divide through here, I get an 8t minus 7. And it's still equal to 0. So if I go negative 2t equals 0 and 8t minus 7 equals 0, this t will equal 0, which is irrelevant in here because it's 0 time before he's startled. He is on the ground. So this is algebraically a correct answer, but in the problem I don't really need it. Here I will add 7 to both sides and divide by 8. So less than 1 second he's back on the ground, so it's pretty quick. 7/8, or you may have ended up putting down 0.875 seconds. Either way is okay. I just leave it as 7/8. One more of these. Now we have a dog. To catch a frisbee, a dog leaps into the air with an initial vertical velocity. Let's change this instead of saying it's 14, because otherwise it's going to be the exact same problem that we just did. Let's say that it's 12 feet per second. So first they want a model for the height of the dog above the ground. So my height is negative 16 t squared plus 12t plus 0. And now we want to know how long does it take the dog to land on the ground. So we'll set it equal to 0. Notice even in the last problem I didn't write the final 0 because I don't need it. My common factor here is going to be a negative 4 and a t. So when I factor that out, negative 4t, this gives me a 4t, and this gives me a negative 3 equals 0. So negative 4t equals 0, and 4t minus 3 equals 0. So again, t would equal 0, but it's irrelevant because we know the dog is already on the ground. And here I'll add 3 and divide by 4. So in 3/4 of a second, the dog is right back on the ground. All right, hopefully you won't find this terribly difficult, this assignment. It is lesson 8.4, and it is page 520 to 521. Actually, it goes to page, nope, it is just 521, sorry. 520 to 521. Problems 4 to 48 even. And then I've got 4 story problems for you. It's 51 and 52 and 54 and 55. Make sure that you read the directions with 54 and 55. It's still vertical motion model, but they're going to give it to you meters per second instead of feet per second, and so the model is a little bit different.